Hello students, welcome to another video of Code with Vinay. In this video, Navigating Boundaries, we'll see why do values wrap around in Java at the boundaries. In a previous video, we saw that the values of integer variables wrap around to the other side when we cross the boundaries. In this video, we'll see why that happens. Let us have a quick recap in case you have not seen the previous video. When we increment the value of a variable which is at its maximum position, it becomes equal to the minimum possible value, which is a negative value. This wrapping also takes place in the reverse case, that is when we try to decrement an integer variable beyond its minimum value, and in that case it becomes equal to the maximum possible value. This is the reason why an integer variable becomes negative if you keep on adding 1 to it, and why it becomes positive if you keep on subtracting 1 from it. Also note that even though we are discussing integers in this case, the same behavior is exhibited in case of other integer types like byte, short, long, etc. Now let us see why this happens. Each data type is allotted a finite amount of memory. For instance, an integer variable takes 4 bytes in the memory. I'm taking an example of an integer variable because it's the most common integer data type. Obviously, the entire discussion will hold for other data types as well. Any variable which is stored inside a computer is internally represented in binary. Let us see how this thing actually works. To convert our regular base 10 numbers into a binary equivalent, what we do is we repeatedly divide the number by 2 till the question becomes equal to 0, and then we take the remainder in the reverse order. Let us see this with the help of an example. Let us take an example of 34. So we'll divide 34 by 2 repeatedly. For example, 2 into 17 is 34, remainder is 0. Then we again divide it by 2. This time 2 into 8 is 16, the remainder is 1. Again the quotient is 8, it's still not 0, so we'll keep on dividing till it becomes 0. So let's move forward. 2 into 4 is 8, remainder is 0. Then 2 into 2 is 4, remainder is again 0. Then 2 into 1 is 2, remainder is again 0. And finally it is still not 1, so we'll divide it once more. 2 into 0 times is equal to 0, and this time the remainder will be 1. And then we have to take it in the reverse order, that is from bottom to the top. And once we do it, our answer is 1 0 0 0 1 0. Now please understand, I told you the width of this inside the memory is 32 bits. Right now it's not 32 bits, it's 1 2 3 4 5 6 bits. So what we'll do, we'll add zeros in the beginning so that it becomes equal to 32 bits like this. And this is how the number 34 is represented in the memory. Now note that this representation is of the positive 34 or plus 34. Now we'll see how negative numbers are represented inside the memory. To represent a negative number in memory, we use something known as the 2's complements method. This is one of the most common methods to represent a negative number in programming languages, including Java. Unlike in regular mathematical notation, we cannot attach a negative sign in front of a number. Everything has to be in binary, that is either 0 or 1. In order to represent a number in 2's complement method, obviously we have to first convert it into binary. Then the first step is we flip all the zeros and ones. That is, we change zeros into ones and 1 into zeros, and then we add 1 to it. Now note that the size is fixed. In case of integer, it is 32-bit. If after adding 1 you are getting a carryover, that is the 33-bit, we simply ignore it. Now let us see this with the help of an example. We'll continue with our earlier example of 35. And we have already seen how to convert 35 in binary. So this is there on the screen right now. Now the first step is we have to flip the digits. That is, zeros will become ones and ones will become 0. Once that is done, we'll add plus 1 to it. So once we add plus 1, This is what we are going to get. I'll explain some portion of it. So 1 plus 1 is 2 in decimal. 2 in binary is 1 0. So 1 plus 1 is 1 0. 0 comes over here as the sum. 1 goes to the carry. Now 1 plus 0 is 1. We write 1 over here. Again 0 goes to the carry. 0 plus 1 1. And then since there are no other digits left, we'll simply copy down all the digits. So this is the binary representation of a negative number 35 in 2's complement method. Now we come to the most important part. In this representation of a negative number, the first bit, that is the leftmost digit, also known as the most significant digit, is very important. I'm talking about this digit marked by an arrow. So this is something known as a sign bit. If this sign bit is 0, it means that the number is positive. If the sign bit is 1, it means that the number is negative. And obviously, since this is minus 35, this is a negative number. This represents a negative number. Now let us see how this relates to the wrapping up of values in Java. So integer.max value holds the maximum possible integer value, and that is 214748367. This value in binary is 0 followed by all ones, that is first bit is 0 and the remaining 31 bits are 1. Now notice the very important point, and that is the first bit is 0. 0 into 2's complement form, all the numbers are stored in 2's complement form in Java. 0 in the beginning indicates a positive number, and this is a positive number. In fact, this is the maximum positive number. The first bit is 0, and that is the important part. Now whenever you try to add any value, for in this case, for example, we'll add 1. See what happens. Once we try to add 1, 1 plus 1 is 0. Then again we take over the carry as 1. 1 plus 1 is again 0. Again the carryover is 1, and this continues. So we get all zeros, but in the case of the leftmost digit, when we add the carryover 1, 0 plus 1 is 1, and 1 in this case is the sign bit, and the sign bit of 1 indicates a negative number, and hence once you add plus 1, or for that matter any other number, to the maximum possible value, this results in the carryover of 1 on the last digit or the leftmost digit, which makes the number negative. And in this case the first bit becomes 1, and this is equal to the minimum value of the integer. To sum up, the size of all the data types is finite. If we add a number such that the result cannot be stored in the given size, the value of the most significant bit becomes 1, leading to a negative number which gives the impression of wrapping. That's all for now. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. If you have any questions or suggestions for improvement, please don't hesitate to leave a comment or send me a message.